Okay, here we are again for another part of one of the blood labs anyway. I'm recording a couple of these at the same time. This blood lab involves doing hematocrits and also doing blood cell counting by the old standard method, which still works just as well as it ever did way back when. I bought myself a hemocytometer on eBay that is from 1947. And I use that to teach with because it's really cool. Came in this box, looks like something from prehistoric times. Sally Adams still makes them. And the hemocytometer is a heavy-duty Microsoft slide that has a microscopic grid printed on it. So when you go under the microscope, you can see the grid there. And if you put exactly the right concentration of your blood cells on there, you can count the cells within a grid, multiply it by 10,000, and tell how many red blood cells you have in every microliter or millionth of a liter of blood. And then you can tell if you have enough or not, because normal ranges for males and females, you'll see on the online or wherever you choose to look. I have here's a look at this file I'm putting on your Canvas site for you. It's called Blood Lab, and it has various things on here, normal values for red blood cells and a microliter of blood and all that. And this is probably backwards on your on this recording. You know, the camera likes to reverse it for you. Here's some things we're going to do with the hematocrit. We're also going to do blood typing on this sheet. So you'll probably want to print out a copy of that and just have it handy while you're going through these labs, so you can write down some stuff. Okay, so the first thing I have to do is get exactly the right amount of blood on my slide. And it's a relatively easy procedure. First of all, I stab myself with and if you've never done a finger stick before, you want to make sure the hand is kind of warm. The person can hold the hand down and let gravity pull blood into it. You can pull from the finger toward the tip if you want to get a little bit more blood. Don't squeeze too hard or you squeeze out interstitial fluid and it actually changes the result. And then while it's kind of pooky out, you make the hole. The blood comes out. And now this guy, here's my hemocytometer, applicator, and it actually allows you to get my glasses off so I can see properly here. I'm going to draw it up in here. Just the right amount. Then I pull in distilled, well, it's not distilled water, it's normal saline. It was distilled water to which the right amount of solute has been put. Pull that in until it fills up just a little bulb. Shake it up some, make sure it's mixed. Blow out some because there's just water down there. And then I put just a drop on my hemocytometer. See, here's the hemocytometer, and I put a drop right on this end, and I put a drop on that end, and it pulls under the slide. Sorry if I'm not pointing right. It pulls under the slide by capillary action and spreads out exactly the right thickness to give you the measurement that you're trying to get. I bumped it. That's the last thing I wanted to do. Oh, okay, so it should be over here somewhere. Oh, here we go. Good, good. Okay, so here, let's focus a little bit. But you can see this grid under here. Look at this grid. So each one of these little squares means something. Let's look up here. Okay. See a little better? See, each one of those little squares tells you something, or it helps you keep your wits together while you're trying to count these cells. And then the big square is what you count. You want to count all of the red blood cells that are in one of these big squares. And actually, you count the red blood cells in 5 of those squares, and that allows you to kind of average them out because they're not all exactly even. What I normally have the class do is each group of 2 or 3 students will count one block, and we average the number of blocks. We may have 7 of them or something like that, multiply by 5 to get our 5 average blocks. But what I'm doing here is I'll show you how to count it. I'm not going to take the time to count every cell on here, but what you do is you count where every cell that touches this line or this one you count, and every one that touches this line or this one you don't. So you don't wind up counting too big an area. For instance, these guys will count. These will not, because they're touching the wrong one. So that one's touching, I'll count it. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 40, 1, 2. Okay, so there's like 40, or so, in that part of it. Now, I've counted one of these ahead of time, and I came out with 114 cells in one of these squares. And what you do, you'll see on your chart that you multiply it by 5, so that would be 570, and you multiply that by 10,000. Again, it's on your sheet. So you count your 5 of them, you average them out. Some are going to be higher, some are going to be lower, but it's spread out, by the time you get 5 of them, you got a pretty good number. So let's say 570 by times 10,000. All you have to do is add 4 zeros to multiply something by 10,000. And you get 5.7 million per microliter. Now, if you look on your chart, you can see that 5.7 million cells per microliter of blood is within the normal range. So my blood is within the normal range for the count of red blood cells. Now you can do this, you can mess around with this, count some, multiply. This looks like this one probably has more than usual in it. This one may have less than usual, that one may have less than usual, and therefore it comes out to an average of somewhere between 100 or between like 95 and say 140 would be a normal range for these guys. You average them out. When I did it, it came out to 114, so that's good enough. Just to show you how this works. Now, where are the white blood cells in here? This is so spread out that you would need like a half acre. Look how far apart these red blood cells are, so you can count them. So because white blood cells are so few, it's very rare that you see them. Plus, I don't have them stained so that they would show up very well anyway, so that would be kind of tough. So here, you're really only counting your erythrocytes, your red blood cells. And I am perfectly normal, maybe only in that way. That's the end of that part of the lab, the blood lab.